I want to tell you something that should disturb you. Not scare you, not confuse you, disturb you, the way a good idea should. Because once you really understand what I'm about to say, you won't be able to look at the world the same way again. And that's the whole point. You are not experiencing this moment. Right now, as you read these words or as someone reads them to you, you are receiving information that is already old. Not old like yesterday, old like a few hundred milliseconds ago, maybe more, because your eyes receive light, and that signal travels down your optic nerve, and your brain does an enormous amount of processing, and only then does something get labeled as experience. By the time you perceive anything, the thing that caused the perception has already moved on. The present moment, as you feel it, is the past. Now, some people hear that and say, well, a few milliseconds, who cares? And that's the wrong reaction. Not because a few milliseconds matters practically. It doesn't most of the time. But because it reveals something deep about what time actually is, and what it means to say you know something now. Let's go slower. Let's be careful. That's the only way to understand anything. Light has a speed, a finite speed. Here's something I want you to take seriously, really seriously. Not just accept as a fact, but feel the weight of. Light travels at about 186,000 miles per second. That sounds fast. It is fast. But it is not infinite. It is a number. A specific, measurable, finite number. What does that mean? It means that when you look at something, you are not seeing it as it is. You are seeing it as it was. At the moment, the light that's now hitting your eye left that object. Look at your hand. The light leaving your hand takes a fraction of a nanosecond to reach your eyes. Your hand, as you're seeing it right now, is technically in the past, immeasurably tiny past. Yes, but the principle is there, and the principle doesn't care about scale. Scale just makes it practical or impractical. Now look out the window at the moon. The moon is about 240,000 miles away. Light travels at 186,000 miles per second. Do the arithmetic. The light from the moon takes about 1.3 seconds to reach you. So you are seeing the moon as it was 1.3 seconds ago. If something happened on the moon right now, an explosion, a change, anything, you would not know about it for another 1.3 seconds. You cannot know. The sun is about 93 million miles away. Light takes about 8 minutes to get here from the sun. So when you look at the sun, don't look directly, but if you could, you're seeing it as it was 8 minutes ago. If the sun somehow winked out of existence right now, right this second, we would have no idea for 8 minutes. We'd still be getting warm, still getting light, still calculating our orbits around something that wasn't there anymore. That's not a metaphor. That is the literal physical situation. The sky is a time machine. Now look up at night, a clear night, away from city lights, and just look at the stars. Every single point of light you're seeing is in the past. The nearest star, Proxima Centauri, is about 4.2 light years away. That means the light you're seeing left that star 4.2 years ago. You are looking at Proxima Centauri as it was over 4 years ago. The star you can see with your eyes, the bright one, Sirius, it's about 8.6 light years away. That pinprick of light in the sky is 8.6 years old by the time it reaches you. And these are the close ones, the nearby neighbors. That fuzzy patch you can see in the Andromeda direction on a dark night, that's the Andromeda galaxy, 2.5 million light years away. The light entering your eye right now left that galaxy 2.5 million years ago. Homo erectus was walking around on this planet when that light began its journey to you. The dinosaurs had been gone for 63 million years before that light even set off. When you look at the night sky, you are not seeing space. You are seeing time. The sky is a record, a layered, multi-depth record of history, all arriving at your eyeballs simultaneously. Light from 100 different eras, all hitting your retina in the same moment. You can't look up and see the universe as it is. Nobody can. It's physically impossible. What you see is a fossil record, incredibly beautiful, but old. Now let's talk about simultaneity. So far, everything I've told you is already strange. But there's something stranger, and this is where Einstein comes in. Here is the question that should stop you cold. If two things happen at the same time in two different places, are they actually simultaneous? Your instinct says yes. Of course, if I clap my hands and someone on the other side of the room drops a cup at the exact same moment, those two events are simultaneous. They happened at the same time. Everyone agrees. But everyone doesn't agree. That's the thing. That's what special relativity says, and it says it very clearly and very firmly and with extraordinary experimental evidence behind it. Whether two events in different places are simultaneous depends on how fast you're moving. Let me show you. Imagine a train, long train, moving fast. Lightning strikes both ends of the train at what seems, to a person standing on the platform watching, like exactly the same moment, simultaneously. The person on the platform sees the flashes from both ends arrive at the same time. They say, yes, those two lightning strikes were simultaneous. Now put someone in the middle of the train. They're moving forward toward the front of the train at the train's speed. Light from the front. Lightning strike reaches them slightly before the light from the back. The front flash arrives first. So to them, the lightning struck the front of the train first, not simultaneously. The front event came first. Both observers are correct. Within their own reference frames, they're each right. The platform person is right. The train person is right. There is no fact of the matter about which one is telling the truth, because the truth depends on the observer. Simultaneity is not a property of events. It's a property of the relationship between events and observers. And now think about what this means. Right now, as you experience this moment, there is no universal right now. There is your right now relative to your motion, your position, your reference frame. Someone moving relative to you at a high speed, and I mean genuinely high, significant fraction of the speed of light. Their right now cuts through space-time at a different angle. Events that are in your future might be in their past, and vice versa, not as illusion, as reality. We have this picture of time. Everyone does. Time flows like a river, from past to present to future, and we're all floating on it together, all in the same moment, all sharing the same now. That picture is wrong. Time doesn't flow the same for everyone. Time runs differently depending on how fast you're moving and how strong the gravity is where you are. This is called time dilation. And again, this is not a theory we think is probably true. This is something we have measured. We have put atomic clocks on airplanes and flown them around the world and compared them to identical clocks left on the ground, and the clocks show different times when they're reunited. Not because of some technical error, because time literally ran at different rates for the moving clock versus the stationary one. We have measured this in particle accelerators. Muons, tiny subatomic particles created in the upper atmosphere by cosmic rays, should decay before reaching Earth's surface. They don't survive long enough, by our calculations. Except they do reach the surface, in huge numbers. Why? Because they're moving so fast, close to the speed of light, that time is passing more slowly for them. From their reference frame, the journey is shorter. From our frame, they last longer than they should. Both descriptions are correct. Neither is an illusion. Your GPS system corrects for this every single day. The satellites are moving fast, which slows their clocks slightly. They're also farther from Earth's gravity well, which speeds their clocks slightly. The net effect is a gain of about 38 microseconds per day. 38 microseconds sounds small, but GPS works by measuring timing signals to extraordinary precision. If we didn't correct for relativity, Einstein's relativity, your GPS would drift by miles per day. The fact that it works is a daily experimental confirmation of everything I'm telling you. What is the speed of light actually telling us? Here is something that confused me for a long time, and I think it confuses most people, and I want to try to undo the confusion. The speed of light isn't special because light is special. Light is special because it travels at the cosmic speed limit, and the speed limit is what's fundamental. There is a maximum speed at which information, matter, causation, anything can travel through the universe. It happens to be about 186,000 miles per second. Light travels at that speed because photons have no mass. If light had mass, it wouldn't travel at the cosmic limit. Something else would. We'd just name that speed after whatever happened to travel at it. The reason this speed limit exists is deep. It comes from the geometry of space-time itself. Space and time aren't separate things. They're woven together into a four-dimensional fabric. Space-time and the speed of light is the conversion factor between the space dimensions and the time dimension. It's not a law someone imposed, it's a structural feature of the universe. And because of that structure, some things are simply not possible. You cannot send information faster than light. You cannot travel back in time by exceeding it. You cannot have an effect happen before its cause, not from any consistent reference frame. Causality, the idea that causes come before effects, is protected by the speed limit. The universe has arranged itself so that cause always precedes effect, but only because the geometry of space-time enforces it. This is not bureaucracy, this is structure. The universe is self-consistent in a deep way, and the speed of light is one of the main threads holding that consistency together. The block universe. Now, I want to tell you the strangest thing, the thing that most physicists believe, but that almost nobody talks about in ordinary conversation, because it's genuinely hard to sit with. The equations of relativity don't have a preferred direction of time. The mathematics works the same forward as backward. There is no variable in Einstein's equations that says now, no arrow built into the fundamental physics that distinguishes past from future. What this suggests, and many physicists take this seriously as more than a suggestion, is that the past, the present, and the future all exist equally. Not that they happened and then disappeared or haven't happened yet, but that all of space-time exists as a single four-dimensional block. The past is as real as the present. The future is as real as the present. We just happen to be at a particular location in that block, and we experience moving through it in one direction because of thermodynamics and entropy. But the block is all there. This is called the block universe, or eternalism. And I'll be honest with you, I don't know if it's right. Nobody does. It's a serious interpretation of serious physics, but there are other interpretations. What I do know is that the equations don't give time any special flowing quality. The flow is something we experience. Whether it's something that exists in the underlying reality is an open question. That should make you uncomfortable. Good, it should. If you're not uncomfortable, you haven't thought about it hard enough yet. Why this actually matters. Someone will say, okay, fine, time is weird, light has a speed, GPS corrections, Andromeda galaxy, very interesting. But what does it mean for me, standing in my kitchen, making coffee? It means this. The way you intuitively understand the world is an approximation, a very good one. It works at the speeds and scales of human life. Newton's physics is a perfectly good approximation for objects moving slowly in weak gravitational fields, which covers most of human experience. But it is an approximation. The universe underneath is stranger, and understanding that it's stranger changes how you ask questions. If you don't know that time can run at different rates, you'll never ask, how does time run differently near a black hole? If you don't know that simultaneity is relative, you'll never ask, what does it mean for cause and effect to be absolute while time ordering is not? If you don't know that the speed of light is a structural feature of space-time geometry, you'll never wonder what other structural features are there and what do they imply. The strange thing is always the doorway. The comfortable, obvious version closes the door. The disturbing version opens it. I've spent my life trying to find where the doors are. Not because I needed to be exotic or to show off, but because the universe is rich in a way that ordinary assumptions hide. Every time I accepted an obvious answer too quickly, I missed something. Every time I sat with the strangeness and refused to paper over it with a comfortable story, I learned something real. So here you are, reading this, experiencing this moment. Except, and I want you to actually sit with this, not just nod, you're not experiencing this moment. The light that carried these words to your eye, the electrochemical signals running through your visual cortex, the processing that turns pixel patterns into meaning, all of that takes time. The moment you're calling now is slightly behind the actual present. Meanwhile, the coffee sitting next to you, if there's coffee, and there ought to be, is emitting light that takes a tiny but ton-go time to cross the room and reach you. You are seeing where the coffee was, not where it is. The star that burned above you last night, Vega maybe, or Deneb, you are seeing it as it was 25 years ago or 1500 years ago. That star may not exist anymore. You have no way of knowing. Somewhere out in the universe, a civilization, if one exists, is pointing a telescope at Earth right now. But the light they're receiving left Earth hundreds or thousands or millions of years ago, depending on their distance. They're watching dinosaurs. They're watching the planet before humans arrived. They think they're seeing Earth now. They're seeing Earth then. There is no contradiction. There is no error. There is only the speed of light, doing its thing, making every observation of distant objects an observation of the past. We are all, always, looking at the past. And we are all, to some observer somewhere, the past. So what's the warning? The warning is, be suspicious of the obvious. Be suspicious of the intuitive. Your intuitions were built for a particular environment. Human scale, human speed, human distances. They are good tools for that environment. They are not good tools for the universe at large. When something in physics seems to violate common sense, The proper response is not to reject the physics. The proper response is to interrogate the common sense. Where did this intuition come from? What was it built to handle? Is this situation within the range it was built for? Usually the answer is no. Usually the counterintuitive thing is the thing that's true, and the comfortable thing is the approximation. Time is not what you think it is. Space is not what you think it is. The present moment is not shared universally. The sky is not showing you now. Cause and effect are preserved, but not in the simple way you imagine. The universe is not obligated to make sense to human brains that evolved to track fruit and predators on an African savanna. But, and this is the part that I find wonderful, that I find genuinely extraordinary, the universe is obligated to be consistent with itself. And it is. Spectacularly, relentlessly. The same equations that describe a muon decaying in the upper atmosphere describe the GPS in your pocket. The same geometry of space-time that makes light travel at a fixed speed makes black holes bend time into knots. It all hangs together. It is hard to understand, but it is understandable. Given enough patience, enough willingness to be confused, enough refusal to accept comfortable nonsense, it opens up. You are living in the past, but you are doing so on a spinning rock, orbiting a burning star in a galaxy rotating through an expanding universe that began 13.8 billion years ago and has been doing remarkable things ever since. The least you can do is notice. That's the warning, and it's also the invitation.